Today's section is operations with sets. When some but not all of the elements of one set are contained in the other, the sets are represented as overlapping circles in a Venn diagram. Elements that are common to two sets are referred to as the intersection of the sets. The intersection of two sets A and B is the set of all the elements common to both A and B. So they're both in A and B. We denote the intersection of A and B as A with an upside down U, B. And that means that X is in A and X is in B. Find the intersection of the sets A and B here. So we just want the letters that are in both sets. So let's see. R is in both. U is in both. And E is in both. That's the intersection. Given the Venn diagram, the given Venn diagram represents the number of students that participated in certain activities while on a spring break trip. Determine the number of students that went both hiking and skiing over spring break. Well, both hiking and skiing, there were 13 students. The union of two sets, A and B, is the set of all elements in A or B. So it's all the elements in A and all the elements in B, not just the ones in common. So A union B is X is in A or X is in B. Find the following unions from these here. So A union B would be all the elements in A and all the elements in B, but we don't want to repeat them. So it would be 1, 2, 3, 4, 5, 6, 8. AUC would be 1, 2, 3, 4, 5, 7, 9. And BUC would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Let U be, I believe, all the letters of the alphabet. M is the letters of math. N is the letter of money. And K is the letters of investor. Find M unioned with the intersection of N and K. So just like with order of operations, you want to start with what's in parentheses. Okay, so the intersection of N and K. So what they have in common. Let's see, no M, there's O in common, there's N in common, and an E. I believe that's it. So now we want all the elements that are in both M and O-N-E. So that would be M, A, T, H, C-O-N-E. For part B, we want the intersection of M with the union of N and K. So N and K, we're going to list everything that's in N and K. M-O-N-E-Y, I, be sure not to list them twice, V, S, T, and R. And then the intersection of M with this green set here would be, let's see, they both share M. They share a T. And I believe that's it. Two sets A and B are disjoint if there's no elements in set A that are also contained in set B. They don't share any elements. They're disjoint. In this case, where two sets are disjoint, the intersection of those two sets would be the null set because they don't contain anything. Let U be all students. A is students with a GPA less than 2.5, and B is students with a GPA greater than 3. Determine if A and B are disjoint and draw a Venn diagram to illustrate the relationship. Well, you couldn't have both a GPA that's less than 2.5 and a GPA that's greater than 3. So they would be disjoint. And so the Venn diagram would look like this. Where they don't overlap. De Morgan's laws, it says that the complement of the union of B is equal to the complement of A intersected with the complement of B. And the complement of the intersection of A and B is equal to the complement of A unioned with the complement of B. For example 6, we want to kind of do a little proof of that first law, okay? So, U is all the letters of the alphabet. A is the letters of hound. B contains the letters of rock. So the first thing we want to do is list the elements of the complement of A union B. And actually before that, we need to list the elements of A unioned with B. So H, O, U, N, D, R, C, K. And then the complement of that would be all the letters of the alphabet that aren't these letters. So let's see. A, B, not C, not D, E, F, G, not H, I, J, not K, L, M, not N, not O, P, Q, not R, S, T, not U, V, W, X, Y, Z. Okay, so next step is to list the complement of A and the complement of B. And then we'll list A complement, the intersection of those two complements. Okay, so the complement of A would be everything in the alphabet except for hound. So, I'm just going to start listing. And the complement of B would be everything that is not R, O, C, or K. So the intersection of that would be all the letters that they share in common. A, B, E, F, G, I, J, L, that's supposed to be an N right there. So L and M, P, Q, S, T, V, W, X, Y, Z. And so now, last step, we need to see that they match. So A, B, E, F, G, I, J, L, M, P, Q, S, T, V, W, X, Y, Z. Yep. So yes, the complement of A union B in our example is equal to the complement of A intersected with the complement of B. Example 7 says, let A be these numbers and B be these numbers. Find the cardinality of A union B. So first find A union B. That's all the numbers of A and all the numbers of B. So 1, 2, 3, 4, 5, 6, and 8. So the complement of A union B, there's 7 numbers in there, so it would be 7. The Inclusion-Exclusion Principle states that the number of elements in the union of two sets, A and B, is calculated by adding the number of elements in set A to the number of elements in set B, less the number of elements that appear in both sets. Kind of look familiar from probability, huh? So you would, to find the cardinality of A union B, you would take A plus B and then subtract off anything that's included in both. A standard deck of playing cards has 52 cards. 26 are red, 26 are black, divided into 4 suits: clubs, spades, diamonds, and hearts, where there's 13 of each suit: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. Of these cards, 12 are considered face cards, 4 kings, 4 queens, and 4 jacks. Find the number of cards in a standard deck that are either club or face cards. So we want clubs or, so that's union, face cards. So we would find that by taking cards, the number of cards, plus, the number of clubs, plus the number of face cards, and I'll move this down. Subtracting off the number of cards that are both clubs and face cards. Okay. So the number of clubs, there's 13. There are 12 face cards. And how many cards are in the clubs, in the suit of clubs, are face cards? 3 of them. So we're going to subtract off 3. So that would be 22 cards in that union. And that concludes our lesson for today.